Okay, these are your graphing absolute value graphs. These are fun. They're also easy. I'm not sure how you are taught to do this in the class you're in. So I teach lots of stuff, but I have enhanced integrated 3. So I don't know what you guys call it at your school, and I know you're in 9th grade. But we teach everything we learn the shape of the function. So these are all absolute value graphs. So you're supposed to know the shape of absolute value, what it looks like, and then depending on where the numbers are, it just shifts the graph. So I'm not sure if you know that or not. So here's what we're gonna do. Just plain old absolute value of X. So I teach my students so they just know what that basic absolute value of X graph looks like. So I'm gonna teach you that first. So by doing like a table of values, I'm just gonna talk you through it. If we plugged in a 0, absolute value of 0 is 0. If we plugged in a 1, absolute value of 1 is 1. If we plugged in a 2, absolute value of 2 is 2. So you would see that line. Coming on the negative side, if we plugged a -1 in, the absolute value of -1 is a +1. And the absolute value of -2 is a +2. So I make my students, this is what all absolute value graphs look like. Starting at the origin, because there's no numbers in here. It starts at the origin, and then it hasn't been moved left, right. It hasn't been moved up, down. There's an invisible 1 in front of here. That's kind of the slope. So from this starting point, you go up 1 over 1 to the right, up 1 over 1 to the left, and it always looks like a V. So that is the basic absolute value graph. So once you know that, graphing these ones should be easy. If you don't know how to do it with the shapes, then you have to do a table of values and just plug in lots of numbers, positive and negative, till you figure it out. But I teach my students the easy way to graph is knowing the shape and then just translating depending on the numbers. So in this graph, you can see the absolute value, but there's 2 numbers attached. So those 2 2's have something to do with it. When you have a number at the end out by itself out here, and it says -2, it's telling you this graph is gonna get dropped down to. So instead of being here at 0, we have to drop it down to, and that's where that point ends up going to. It ends up going down here. And then it's still gonna be a V shape, except that 2 in front is a change in the slope, or we call it a vertical stretch or a dilation. So instead of going up 1 over 1, like the original one we did up here, we're gonna go up 2 over 1. So from the middle, we're gonna go up 2 over 1 to the right and up 2 over 1 to the left. So it takes that V and it makes it steeper. And that's that graph. All right, next. Ooh, there's lots of numbers here. So here we go. Graphing made easy. Still gonna be a V because it's absolute value, but it's been moved. The 2's out here on the end, it's gonna move the graph up 2. So it's gonna go up 2. When it's done inside the absolute value, that moves it away from the origin left and right. Because it's X plus 4, it actually moves it to the left 4. And the reason that seems weird, but if you took X plus 4 and said, you know what, it usually is at 0, and then you solve for X and you move the 4 over, you see that it actually moves over to -4. So instead of being at the origin, it's gonna move to the left 4, and it's gonna go up 2. So there's where the turn's gonna take place. And then, instead of opening up 1 over 1, now we have a -2. I'm gonna put a 1 underneath it. So instead of going up, we're gonna go down 2, and over 1. So from here, down to over 1 to the left, down to over 1 to the right, and this absolute value flips upside down. Okay? So that is how you do absolute value graphs. Easy.